Recording. Okay, so let's get started. So today we will be continuing looking at Unit 3.6, and we are going to investigate some of the examples from CodeHS, and then we'll have an opportunity to get started on one of the homework questions as well. So that'll be part of our practice. Okay. All right, I went ahead and put that Pear Deck link in the chat again because I saw some people join us. So last class with 3.5, we took a look at these flowchart things, right? So we're going to continue using those to kind of conceptualize what's happening in these code examples. So this comes directly from example 3.6.3 on CodeHS. And what I would like us to do is to fill out the flowchart so that it represents the code chunk on the left. Don't worry about putting in values for has bike or has helmet yet. We just want to represent the actual code, like the logic of the code on the left. So you'll notice that you kind of want to start maybe around line 19 because that has the actual Boolean expression we need to evaluate. That's going to go into the diamond here. Then what you're going to do is you're going to tell me what's going to happen if that Boolean expression is true and what's going to happen if that Boolean expression is false. So at this moment, you're going to want to go ahead and flip to the Pear Deck and go ahead and annotate on your screen the Boolean expression that gets evaluated and what the outcome will be if it's true or false. So I'll give you a minute or two to work on that, and then we will check it together. Okay, I see that most of y'all are done. A few of you are kind of tweaking a few things. So I'm going to go ahead and I'm going to select a few of these answers to go ahead and look at. We've got a little bit of variation and we'll talk about it. So come on back to my Pear Deck screen. or sorry, to my shared screen so that you can see what I'm looking at. And I'm going to show some responses here. Okay, so this first one recognized that we need to determine if this Boolean expression from line 19 is true or false. Because that is the Boolean expression that's being assigned to cannot bike, which is being evaluated down here, right? Now I did see someone put, hopefully they didn't change it, they actually put the cannot bike there because that's what you see on line 25. That's fine too, because if we look inside of cannot bike, it's being determined by this compound Boolean expression, okay? So yeah, let's continue looking at this first one. So we got that compound Boolean expression. And then to determine what happens if it's true or false, we're going to take a look at this conditional block right here from lines 25 through 32. So if cannot bike turns out to be true, that means that you may not bike, right? That makes sense. If it's true that you cannot bike, you may not bike. So down here on the true side, you see you may not bike. And then if it's false, it's going to fall into the else clause, which says you may bike. Yeah, so that works. And just looking at the other ones here, I think this person was trying to convert, make a equivalent Boolean expression. It's almost there. We're actually going to look at that as well. So, and remember, you also have to negate the and when you do that. So this should be an or. And this one also does a great job. And then this one, like I said, they put cannot bike, which is the same thing as saying that compound Boolean expression, because cannot bike is actually storing the value from that compound Boolean expression. All right, cool. Well done, everybody. So now let's go ahead and now that we know what our flowchart actually looks like, let's take a scenario where the user has answered the first prompt. So here's the first prompt on line 10. Do you have a bike? Enter true or false. Let's say they entered true for that. And then let's say that they answered the second prompt, which is do you have a helmet? Let's say they entered false for that. So what you're going to want to do is you're going to want to put those Boolean values in the appropriate variables up here, and then trace through the flowchart to indicate which direction it goes in. Okay, so I'll give you a minute to do that. Okay, so I see that y'all pretty much put your answers. I see one person says they're confused. That's totally okay. We're gonna go through this. We'll do it slowly, and hopefully you'll see how it's gonna work. And let me know if you have any questions, follow-up questions afterwards. So let me go ahead and show one answer. Let's see what's going on. Okay. So if we look at the code, we see that the first prompt asks is if you have a bike, and it asks you to enter true or false. And I said, let's pretend that the user put in true. So that means that true is going to be stored inside of has bike, right? We see that this line says has bike is going to get that next Boolean from our input. Okay, so true goes inside of has bike. We have that here. Cool. Now, on line 14, we're going to ask the user if they have a helmet, and they're going to enter true or false. I said that the user is going to go ahead and enter false for that second one. So that means that has helmet is going to get that value of false, and we can see that it's now being stored by has helmet. Okay, so we have true for has bike, false for has helmet. Awesome, that's great. So now we're just going to use those two values to trace through the rest of our flowchart. Okay, so we see that the compound Boolean expression here is not has bike and has helmet. So let's ignore the not for just temporarily. And let's just look at the inside. So we have has bike and has helmet. Okay, so we know has bike is true, so we bring that down. And we know has helmet is false, so we bring that down. So at this point, we have, let me put a box around it. We just have true and false, right? We have true and false. So I'm going to go ahead and put the and up here as well. Okay. Now we know that in order for an and to evaluate to be true, what needs to happen? What's the only case where an and statement evaluates to true? What needs to happen? Feel free to type it in the chat or hop on the microphone. All right, Brianna says that both sides of an and have to be true for this to evaluate to true. That's absolutely correct. In this case, we don't have both sides as true. We have at least one side that is false, so we know that this whole thing is going to be false, right? This whole thing is going to be false, but we don't stop there. We have this not symbol here. And so this student recognized that they had to also have the not here, right? So we have not false, so we're going to flip it to the opposite. The opposite of false is going to be true. So not false is true, right? It's just like we're flipping a light switch. We can think of false as being off and true as being on. And so if we see a not false, we're going to flip that light switch to the on position, meaning that now it's true. Okay. So now, since we know that this evaluates to true, we can travel down to the true side and print out you may not ride a bike. And that makes sense, right? Because you know that you have to both have a bike and a helmet in this scenario to bike. And one of those is false. You have a bike, but you don't have a helmet. So guess what? You cannot bike. I hope that helped for any of you who were confused with that process. Please let me know if you still are not clear. We're also going to practice another one to give you a chance to kind of check your understanding. Okay, but at any point, feel free to interrupt me on the microphone or type a question in the chat. Okay, I'm going to go ahead and clear my annotations. And let's go ahead and take another example here. There we go. Okay, so on this screen, I know you can't draw on this screen yet. The next screen you'll be able to. So take a look at this screen. This, I'm going to say, is an equivalent Boolean expression to the one that we had back here, right? Back here we had not has bike and has helmet, but using De Morgan's law, we can convert it to this equivalent Boolean expression, right? We move out the not operator to each element, and then we flip the and to an or. Okay, but what we're going to do is we're going to check and we're going to verify that this does indeed give us the same result, okay? So let's verify by taking those same inputs. So again, let's say that the user enters true for has bike and false for has helmet. Go ahead and now annotate this flowchart in a similar way, but now we're using the equivalent Boolean expression, and we should get that same true result. But I want you to show your work, right? So you're going to bring down those values to the conditional, and you're going to show me how you find that it is indeed true. All right, I'll go ahead and give you a moment, and then we'll check it. All right, careful. I see someone put false for has bike and true for has helmet. That should be the other way around, right? True for has bike, false for has helmet. Careful. Okay. So I see many correct answers, and I see some that are like maybe partially done, either because you didn't have enough time, or maybe you're just stuck, and that's totally fine too. So I'm gonna pick one of those, the ones that had like a good start but just didn't like finish all the way. And we're gonna take this as an opportunity to learn more deeply what we need to do for the next steps. So I'm gonna go ahead and show the students' work. So they recognize that has bike is going to get that true. They're going to have a bike, but they're not going to have a helmet. So that has helmet is false. And the student also recognized that, okay, we have to bring those values down whenever we see that variable name. Awesome. Great first step. Now, the next thing we need to do is, okay, we have not has bike. We know that has bike is true, right? We brought that down. But now we also need to bring up that not symbol, right? So since this is actually not true, that means that it's actually false. Okay, so not true is the same thing as false. So I'm going to go ahead and say let's say let's just cross that out maybe. Cross that out and we'll have false. Okay. But we're not done yet. We're not done yet. I see that you drew that line of false. We're not done yet. That's only one half of the puzzle, right? We've got a side that's false. We have an or here, which means we're still in the running to figure out if the whole thing is true or false, right? So remember, for an or, only one side has to be true for the whole thing to be true. So now let's take a look at the right-hand side. So you saw that you had to bring down that false from has helmet. But again, oh, you're anticipating. Okay. Again, we have to bring up that not, right? And you do this for me, the person that is annotating this. What will not false equal? Go ahead and write that next to that equal sign. What do you think? So in other words, what's the opposite of false? Yeah, there you go. So go ahead and bring that T, that true, right next to this equal sign right here. Bring that right over here. There we go. So not false is indeed going to be true. Okay, so now let's clean this up a bit. We know that the left-hand side is false, so let me clear up some of these annotations so we can clearly see what we're really looking at here. Oh, I see that part's actually yours. Okay, so we've got false or, and then true down here. Let's go ahead and write that in. So I'm just going to ignore these annotations. And we decided the left-hand side is false and the right-hand side is true. We've got an or in the middle. So we know that only one side of this compound Boolean expression has to be true for the whole thing to be true. And so that's why when you put this line here indicating that the whole thing is true, that's why it's correct. So indeed, we get the same solution as the previous problem because this is an equivalent Boolean expression, right? Equivalent to the one that we saw in the last exercise. Awesome. So hopefully that clears it up a little bit for you. And like I said, we're going to be continuing to practice this. So don't worry if it hasn't clicked just yet. Okay. Any specific questions on this one? Anything that isn't clear that you have a specific question about? Okay. And you all know that you don't necessarily, if you don't want to speak on the microphone, your microphone is broken, or if you don't want to say it in the main chat, you can always direct message me or email me later. It's totally fine. Okay. So let's see, we got about 4 minutes left. So let's see. Oh, thank you. Thank you so much for adding those annotations. Yeah, that's great. Yep, that is the or symbol. Okay. So let's go ahead and, okay. So this is where we're gonna start on the homework problems. We're gonna work on organizing our thoughts to be able to solve this problem from the homework set. So the first problem on CodeHS that we're gonna do for homework is 3.6.5. And today we're just gonna set it up. So let's see, let's go ahead and read through the directions. So they give you a program that reads input from the user to determine if the user can ride the roller coasters and if they can swim in the pools at an amusement park. How exciting. Okay, so there are two Boolean expressions that are needed in order to determine these. Right now, we're just going to focus on the first one. We're going to focus on whether or not we can ride on a roller coaster. Okay, and we can see that that Boolean expression is not old enough and tall enough. That's going to determine if we cannot ride. What I would like you to do is use De Morgan's laws, which we covered last class, to write the equivalent Boolean expression. So the first step, I realize I put the wrong, this is for going the other direction. The first step is that we're going to distribute this not inside to each of these Boolean variables. The second step is that we're going to switch the and to an or. And I see some of you already working on this on Pear Deck. I'm going to give you just another minute in case you haven't started yet. So go ahead and write the steps. And then in step number 2, you should have an equivalent Boolean expression. All right, so let's go ahead and I'm going to show one student example and we'll talk about how it fulfills the requirements of the steps. So let me go ahead and show one response. Okay, so here's the original one right here. That's the original statement. Now the first step we want to do is we wanted to take this not symbol and to distribute it to each Boolean variable. So old enough and tall enough should get that not distributed to it. So we see that right here in step number 1, not old enough and not tall enough. But we're not done yet. Now we need to switch our ands to ors. Okay, so you see that this and right here gets flipped to an or down here. And that's the final step. So we can conclude that this compound Boolean expression is equivalent to the one on the top. And that's through using De Morgan's laws. Okay, so again, the steps there was distributing that not symbol to each Boolean variable and then flipping the and to an or. Okay, let me know if you have any questions. Okay, and let's go ahead and there's just one more slide I want to do and then we'll call it a day. Okay, so this one's going to focus on the second part, the second Boolean expression. So you're going to do the same exact thing. You're going to use those steps to find the common Boolean expression. And again, I apologize for putting the wrong one here. So we want to distribute to each Boolean in the parentheses. Yay, I'm so excited because the person who said that they were lost gave us a try. And let's check out what that person did. Okay. This again is going to be a great learning opportunity for everyone. Excuse me, I'm losing my voice. Whew. Okay. Let's go ahead and um, where am I? There we go. Show responses. Okay. So awesome. This person brought for the first step, they brought in that not operator. They brought in that not operator, right? To can swim and has life jacket. And actually, this person didn't realize it, but they did both steps at once. This is actually the correct answer right here. You could have stopped here because notice that you flipped the or to the and already, right? I have been doing it in 2 steps just to make it very obvious that we're doing it step by step. But you flipped it here and then you went on to flip it down here, so you kind of flipped it back. So actually, you were correct right here on step number 1 because you did both steps at the same time. So you brought in that not operator to each Boolean value, and then you flip the or to the and. So this is no, it's totally fine. I like that we have an opportunity to look at that because I've actually done that too. When I was making the slides, I actually made that mistake as well. So just be really careful and make sure that you're only flipping it once when you're bringing in the not. But yeah, this is the correct answer. Okay, any questions? I think the next slide is just those answers. So when we meet tomorrow, hello voice, we are going to do I found out that what we were doing was called mob programming, M-O-B, mob programming, mob programming. It's like pair programming, except it's more than 2 people. And so that's what we were doing last time when we were programming together, and we're going to do that tomorrow, starting with this amusement park program. And then we'll see if we can we'll at least do this one, amusement park, and the next one together. I might have you do the third one on your own and then see if anyone has questions about it on Tuesday. Okay, so I'll go ahead and upload this video after class.